Question 4.3, video 2, which is day 2. Now we learned a lot of things on day 1. We learned the definition of sine, cosine, tangent, and their reciprocals. We learned how to find them. We learned about the identities to link them all together. Well, now we're going to get a little more specific. We're going to talk about our special angles. These are just like special people in our lives. Special angles are angles we're going to spend a lot of time with, and we're going to love it. Sometimes we're not going to have so much fun, but we're going to love it. Now, the special angles come from our special triangles. We have 2 special triangles. We've got the 30, 60, 90 right triangle, which in radian form is pi over 6, because that's 30 degrees, pi over 3, which is 60 degrees, and pi over 2. And we have the isosceles right triangle, which is the 45, 45, 90, which is pi over 4, that's 45 degrees, pi over 4, and then pi over 2. Now when we're looking at these triangles, we have to have these triangles memorized. Remember, this is our 90-degree angle. So this is our 30-degree angle because it looks smaller than this single right here, which is 60. That's our 90. When we look at the sides of a 30, 60, 90 right triangle, we've actually done an example with these very sides. I always remember them in order, 1, 2, square root of 3, because 1, 2, 3, it just kind of makes it easier for me to remember. So 1, 2, square root of 3. Then I remember the relationship between angles and their sides. The longest side is across from the longest or biggest angle. So biggest is across from biggest. So when I'm looking at these sides, 1 is the smallest of these 3 numbers, so 1 has to be across from the smallest angle. The biggest side, which would be 2, has to be the hypotenuse. The middle or the medium size is the medium angle. So 1 is the smallest side, so it goes across from the 30-degree angle. 2 is the biggest, so it goes across from the 90-degree angle. 60 is in between, so square root of 3 goes with him. So 1, 2, square root of 3. When we look at the 45, 45, 90, that one's easy because this is 45, this is 45. So whatever this side is, it's got to be the same as this side. Those proportions are 1, 1, square root of 2. So these have to be 1s because those sides are equal. They have to be the same. The hypotenuse is square root of 2. So 1, 1, square root of 2. You need to put this once again in your memory banks. So we're loading up your RAM in the old head there. You have to memorize your trig functions, their definitions. You have to memorize these trig identities and the special triangles. The only way you're going to get those in your memory banks is to continually write them down over and over again. So when I'm looking at the 30, 60, 90 right triangle, I want to redraw that every single time to practice so that I'll be very good at it and I'll know 1, 2, square root of 3. Now I'm looking at the 30-degree angle, so I'm going to kind of ignore the 60-degree angle for right now. So that means when I'm looking at the sides, this side is my adjacent, this is my opposite, this is the hypotenuse. So the sine of 30, remember sine is opposite over hypotenuse, so that's going to be 1/2. Adjacent over hypotenuse is your cosine, so that would be square root of 3 over 2. And then tangent, you can take sine divided by cosine, or you can do opposite over adjacent, which is going to be 1 over square root of 3, which rationalized is square root of 3 over 3. Okay, so to find the 60, I'm going to redraw that triangle. The more I draw it, the more likely I am to remember the proportions of those sides. Practice does really make perfect. That's why that is a saying. Practice makes perfect. I'm looking at the 60-degree angle here, so I'm going to kind of cover up the 30. Looking at my 60-degree angle, this is his adjacent side. This is his opposite side. This is the hypotenuse no matter what. Always, I'm just going to write it out. Sine is opposite over hypotenuse. I'm either going to write it out or say it to myself. I want to make sure that I have it down cold because our test, there'll be a calculator and a no calculator section. Adjacent over hypotenuse is cosine, so that guy's 1/2. Tangent is opposite over adjacent, or you can take sine divided by cosine. Either way, you'll get the square root of 3. Now, something I want you to notice about the sine of 30 and the cosine of 60. If you notice, those are exactly the same. They're both 1/2. That is not by accident. Because they're in the same triangle, one guy's opposite side is the other guy's adjacent side. So what happens is the cosine of one angle is equal to the sine of 90 minus that same angle, or the complement. Okay? It goes the other way. The sine of theta is equal to the cosine of its complement. Either way, the cosine of 30 is going to equal the sine of 60. How interesting. Now let's look at our 45, 45, 90. That's a different triangle. I only need to talk about the 45, so I'm only going to write the 45 in one position. That way I don't have to scribble it out up here. The sides, 1, 1, square root of 2. Well, the sine is going to be opposite, and according to where I'm looking at this moment in time, I'm looking here. So this is my opposite side, my adjacent side, my hypotenuse. So opposite over hypotenuse is 1 over the square root of 2. When I rationalize that, I get square root of 2 over 2. Now when I look at my cosine, that's adjacent over hypotenuse. Well, opposite side and adjacent side are exactly the same. So my cosine is going to be the square root of 2 over 2, just like sine. And that makes sense because 45, he is his own complement. So the sine of 45 has to equal the cosine of the complement, which is 45. Anybody else getting goosebumps right now? This is good stuff. Tangent, you can look at opposite over adjacent, which would be 1 over 1, which is 1. Or you can look at sine divided by cosine, which is 1. Okay, so this is spelled out again for you. The sine of one angle is equal to the cosine of its complement. They're going to ask you to find things without the use of a calculator. Okay, so we have to know these cold. Now notice I'm asking you to find the sine of 30, the cosine of pi over 3, the tangent of pi over 6, the secant of pi over 4. Those are all special angles, so I'm going to draw my triangle. Notice I am drawing it again. I'm not going to look at the ones I already have because I want to make sure that I understand these angles. So I'm going to draw them over and over and over until I have them down. 1, 2, square root of 3. So when they ask me for the sine of 30, I know that's opposite over hypotenuse. So there's my 30. The opposite side is 1. The adjacent, or the hypotenuse is 2. So that's going to be 1/2. Cosine of pi over 3, that's the same as the cosine of 60. Because remember, pi is 180, so 180 divided by 3 is 60. So look at your cosine, look at your 60, adjacent over hypotenuse, so 1/2. But we also could have used this little identity up above. Tangent of pi over 6, that's the same thing as the tangent of 30 degrees. So that's opposite over adjacent. So there's my 30-degree angle. Opposite is 1, adjacent is square root of 3. So that gives me square root of 3 over 3. Then we have the secant of pi over 4. That's the secant of 45. Well, secant is hypotenuse over adjacent. So we're up here at this triangle. Hypotenuse is square root of 2. Adjacent side is 1. So I get the square root of 2. Okay? So they gave me a trig function. They gave me the angle. I looked at the corresponding triangle, and I looked at the definition to come up with my answer. Well, now we're going to go backwards. Whenever they say without a triangle, that means it's a special angle. So I'm going to draw my special triangles. Notice that's, what, about the 4th or 5th time I've drawn this out. Just in this exercise alone, I want you to draw these out every time you do one of your homework problems. We are going to be so good at drawing these out, we're going to see them in our sleep. That means we're going to be really good at it. All right, so now they're changing the rules a little bit. They're wanting me to find out which angle it is that has the trig function. Before, they gave us the angle. We had to find the value of the trig function. Now we know the value, we got to find the angle. Now we may have to change this into a fraction so that we can do both sides, that ratio. So it's kind of like slope in that aspect. So when I see tangent is 1, put your 1 over there, or under there. We know tangent is opposite over adjacent. So which one of these triangles has an angle that has an opposite side of 1 and an adjacent side of 1? Please remember the only options we have are 45, 30, and 60. Well, to get 1s and 1s, I have to be at the 45. Well, if I'm in the 45, 45, 90 right triangle, that is excellent because it's either the 45-degree angle or the 45-degree angle. Either one you pick, you're right. Now, what I will ask you to do is tell me what the angle is in degrees and then also what it is in radian measure. So 45 degrees is the same as pi over 4. So we get to practice our 4.1 at the same time. Yay. So now we've got cotangent of square root of 3. I'm going to put that over 1. Remember, cotangent is adjacent over opposite. Well, the only triangle that has a square root of 3 is the 30, 60, 90 right triangle. So we're at this one. Now I have to decide, is it the 30 or the 60? This time I could give the wrong answer, not like, oh, it's 45 or 45. So I need to actually look at which angle is adjacent the square root of 3 and is opposite from the side of 1. Well, 60 is adjacent the 1, so it isn't 60, it's our 30. So we have 30 degrees. What is 30 degrees in radians? Pi over 6. Okay. Then 12, I'm looking at that guy right there. Let's change colors again. Sine is opposite over hypotenuse. So I'm looking at a square root of 3. Square root of 3, once again, I'm at the 30, 60, 90 right triangle. So I am looking which of the two angles, is it 30 or 60, that is opposite the square root of 3 and has a hypotenuse of 2. Well, both angles have a hypotenuse of 2, so it's that opposite side that really narrows it down. 60 degrees is opposite that square root of 3. So 60 is our man, and that would be pi over 3. So without the use of a calculator, it has to come down to one of these two special triangles. So we draw it and we are ready to go. They will be asking us to find the angle without a calculator, but they will be asking us to find it with a calculator. In order to find it with a calculator, we are going to use what's called inverse trig functions. In order to find these inverse trig functions, we are going to, it's so easy because the inverse of tangent is tangent to the -1 power, okay? It's not really to the -1 power, it's that notation. It looks like a -1 power, but it is that function notation, remember that we learned? Well, what we need to do is we need to get rid of that tangent so that we can have theta equals. We're solving for theta, so just like x, we need it by itself. So what we need to do is inverse tan both sides. So I will inverse tangent my tangent. I'm writing it out the long way this first time, but we'll write it out shorter due to our space. So that inverse tangent and tangent are going to cancel out on the left side. So I end up with theta. On the right side, however, I need to actually put that in the calculator. Okay, let me see if I can figure out how to get my calculator going here. Hang on, look at that, pretty fast. Now when you're looking at your graphing calculator, first thing I want you to do is look at your mode. When you hit that mode button, I want you to look at your radian measure down here. Let's change that to degrees because we're a little bit better at degrees, so I'm going to change that. Now remember, we were finding the inverse tangent of 0.4875. So notice your buttons down here. You have sine, cosine, and tangent. Right above them, you have their inverse trig functions. So I'm going to hit second tangent. So you have that tangent -1, and then I'm going to put in 0.4875 in the parenthesis and hit enter. So I end up with 25.989 degrees. Remember, we will be rounding everything to 3 decimal places. Well, we want to be as accurate as possible, so even though we are going to be rounding this answer when we write it down, when I find my radian measure, I don't want to round it. So I'm going to take this answer, I'm going to multiply it by pi, and divide it by 180, because that's how you switch it from degrees to radians. Hit enter, and I get 0.454. Okay, so when I go back to my answers here, I have my angle equals 25.989 degrees, which is 0.454 radians. Remember, radians, you don't put radians, there's no little symbol. Without anything, that's your radians. With the degree symbol, that's your degree. So those are the two answers that we're going to be looking for. So looking at number 14, we're going to have to inverse sine both sides. It's just an operation, just like logarithms or taking the square root of both sides. So we're going to be looking for theta equals the inverse sine of 0.9320. So when I put that in my calculator, let me switch back. I know there's got to be a more techie way to do it, but second sine, because we want inverse sine, of 0.9320, close that parenthesis, that gives us 68.749 degrees, multiply by pi, divide by 180. Oopsie, no parenthesis. I didn't start a parenthesis, I shouldn't end one. And then I hit equals. Ooh, this one's a good one. I've got 1.1998. That 8 is going to round us up. So that actually means our answer is going to be 1.200. So we write them down. Theta equals 68.749 degrees. You've got to put that degree symbol there or people are going to think that's radians, which would be wrong. Okay. And now for our last one. Ooh, this one's a tough one. It's secant. If you notice on your calculator, you don't have a secant button. You have a sine, cosine, and tangent. So who is secant the reciprocal for? Why, cosine. So I'm going to take the reciprocal of the left side, so I'm going to take the reciprocal of the right side. So I'm looking at 1 divided by 11.47. So now I'm going to inverse cosine both sides. So I've got theta equals inverse cosine of 1 divided by 11.47. Okay, so let's put that in our calculator. Okay, let's say we forgot to take the reciprocal of the right side and I put in 11.47, what's going to happen is my calculator is going to give me an error message because remember, sine and cosine could not have an answer bigger than 1. So if you put in 11.47, that is bigger than 1, so the calculator doesn't like that. So what we want to do, that's going to help us figure things out. It's 1 divided by 11.47. We forgot to take that reciprocal, so the calculator can help us out. Then we're going to hit equals. So we've got 84.998 degrees, multiply by pi, divide by 180 to find the radian measure. So I get 1.484. Be careful of your rounding. Rounding does matter. Okay, so we have our angle in degrees and radians. So you can kind of already see that, well, wait a minute, when I didn't get to use my calculator and it pertained to the two special triangles, I actually got done faster than when I got to use my calculator. And that's because of all the decimals. So just because it's a special angle doesn't mean it's going to be horrible. So now when we look at these are kind of some of the types of problems you might see in your ACT where they're trying to get you to understand the relationship between your sides. Now you've got two different ways that you can find these answers. They've told you this is a 30-degree angle, so you could go back to your 30, 60, 90 right triangle and figure out your proportions. Or now you can use your trig functions. Look at the angle that you have, 30. This is the opposite side. This is the hypotenuse. So which trig function is going to link all three of those pieces of information together? Well, sine. So that's going to be the sine of 30 degrees is going to equal opposite over hypotenuse, so x divided by 10. So what would I do to solve for x? Multiply by 10. So 10 times the sine of 30 degrees equals x. So I can put that in my calculator and come up with the answer, or I can think about my 30, 60, 90 right triangle. I know the sine of 30 is 1/2, so I've got 10 times 1/2, which is 5. Now looking at the sides of your triangle, you've got your 30-degree angle here. Remember, this is 1, 2, square root of 3. So if this is 10 and that's twice as big as this side, you know that's going to be 5. These are proportions. So whatever the length of this side is, my hypotenuse will be twice as big. And this side will be square root of 3 times as big. So keeping that in mind with my 45, 45, 90 right triangle right here, well, I know this side's 5, so I know this side's 5. Remember your proportions, 1, 1, square root of 2. So your hypotenuse here is going to be square root of 2 times what these sides are. So that r has to be 5 square root of 2. Okay? So no matter what you have, your 45, 45, 90, it's always in that proportion, 1, 1, square root of 2. So if I tell you that this side is 25, this side would be 25, this side would be 25 square root of 2. We don't even have to lift a calculator to get that answer. So your assignment today is now add on to all the other things you are currently memorizing. Those definitions of your trig functions, those identities, those special triangles, going back and forth between the trig function and the angle and the trig function. All right, we'll see.